Bismillahirrahmanirrahim. So consider the circuit in figure 1 and find the value of the voltage across the capacitor. This is the capacitor. Assuming that the value of Vs of t is equal to 10 u of t volts, and assume that at t is equal to 0 minus 1 ampere current flows through the inductor and plus 5 volt is across the capacitor. So the initial conditions are also present, and let's solve the circuit using the Laplace transform. So we are given that the value of Vs of t, the given data, Vs of t is equal to 10 u of t volts, right? And assume that at t is equal to 0 minus 1 ampere flows through the inductor. So let's assume that the current through the inductor is I naught t, right, at time 0. So I 0 negative, this is minus 1 ampere, and flows and plus 5 voltage across the capacitor. So let's the voltage across the capacitor be V naught t, right? So at time 0, so that is V0 negative, V00 negative is plus 5 volts. So we can transform the circuit in the Laplace to the Laplace domain. So for that, the Vs of t will be transformed to Vs of s, right? And 10 u of t will become 10 over s. The Laplace transform of u of t is 1 over s, so 10 of u of t is 10 over s, right? And we need to transform these inductors also, but this inductor is with an initial condition. So we can transform it in two ways. Either we can model it as an inductor in series with this voltage source here. So this will be SL and this will be IL0 negative. Or we can transform it another way. We can model this inductor like this, SL in parallel with a current source like this. So this will be still SL and this will be I0 negative over S. We will choose this method because it will be easier to apply nodal analysis if we transform it this way. So the inductor 5 Henry, this will become SL, which is equal to 5S, right? The value of L is 5, so 5S, and the current source will be I0 negative over S, and that is I0 negative is minus 1, so that will be minus 1 over S, right? And similarly, the capacitor, it also has an initial condition, and it can also be transformed in two ways. We can transform it like a capacitor in a series with a voltage source. So this will be 1 over SC, and this will be V0 negative over S, right? Or we can transform it like this, a capacitor in parallel with a current source. So this will be 1 over SC, and this will be C multiplied by V0 negative. So we will use this equivalent model for our purposes, because this will facilitate node analysis here, like we said for the inductor. So the capacitor is 0.1 farad, so this will become 1 over SC. So C is 0.1, so that is 10 over S, right? And the current source CV0 negative is 0.1 multiplied by 5, that is 0.5 or 1 over 2 amperes. So let us redraw our circuit. So V of S, this is 10 over S here, right? And this resistors remain the same, 10 over 3 ohm, and we have this inductor here, and this is in parallel with this current source. This is SL is 5S, and this is minus 1 over S, and this then is in parallel with this capacitor, and then this is due to the initial condition we have a current source here in parallel with this capacitor. So the capacitor is 10 over S, and the current is 1 over 2 ampere, right? So the voltage across the capacitor in the frequency domain, let's call it V naught. This was V naught T, so we call it V naught S, V naught of S here, and let's assume this is the ground node. And now we can apply node analysis. This is the single node that we need to solve for, and this V naught S will give us the voltage across the capacitor in the frequency domain. And then we can find the inverse Laplace transform to find V naught T in the time domain. So V naught minus 10 over S divided by 10 over 3, right? 10 over 3 plus V naught over 5S plus plus this current here, and this is minus 1 over S. So this is minus 1 over S, right? And then plus V naught over 10 over S, and then this is minus 1 over 2, minus 1 over, and this is equal to 0, right? So let's take a look at this again. This is V naught minus 10 over S divided by this 10 over 3 plus V naught over 5S, and this current here, this is minus 1 over S plus V naught divided by 10 over S, and minus 1 over 2 ampere, because this current is entering the node. So now this becomes 3 into V naught minus 10 over S divided by 10 plus V naught over 5S minus 1 over S plus S V naught over 2 minus 1 over 2 is equal to 0, right? So we can multiply throughout by 10S, right? So let's multiply throughout by 10S. So this will be 3S into V naught minus 10 over S plus 2V naught minus 10, right? And plus S square V naught and minus 5S, and that should be equal to 0, right? So let's expand this further. So this is 3S V naught, and then minus, this will be 3S into 10 over S, so that is 30, right? S cancels with S, and 3 multiplied by 10 is 30, plus 2V naught minus 10 plus S square V naught minus 5S is equal to 0. So let's collect all the terms containing v naught. So this is s square, right? Then we have 3s v naught. There is no term with s and v naught, right? So plus 3s, and we have this one, we have this one, and then we have this v naught here, plus 2. So s square plus 3s plus 2 into v naught. Then we have the constant terms. So this is we will take it on the other side. So that is 5s, right? Minus 5s here, and the right side this will be plus 5s, and minus 30 and minus 10, that is minus 40, and this will be plus 40 here. So we can write v naught of s is equal to 5 into s plus 8 divided by s square plus 3s plus 2, right? So let me write the v naught term here. So that is this term, 5 into s plus 8 divided by s square plus 3s plus 2, right? So we can factorize this, 5 into s plus 8, so that will be s square plus 2s plus s plus 2, right? So v naught s is equal to 5 into s plus 8 divided by s into s plus 2 plus 1 into s plus 2. So v naught s becomes 5 into s plus 8 over s plus 1 into s plus 2. So this is the Laplace transform of the output voltage across the capacitor v naught t. So we need to expand it using partial fractions so that we can find out the inverse Laplace transform. So let v naught is equal to 5 over s plus 8 divided by s plus 1 into s plus 2 be equal to a over s plus 1 plus b over s plus 2, right? So multiply throughout with the s plus 1. So this will be s plus 1 multiplied by v naught, right, is equal to, this will become 5 into s plus 8 divided by s plus 2, and that will be equal to a, right, and plus b into s plus 1 over s plus 2. So now let s plus 1 is equal to 0, that is s is equal to minus 1. So this will result in all terms containing s plus 1 is equal to in becoming 0. So this will disappear, and we will have a is equal to this term then, right? So we can write a is equal to s plus 1 v naught, while s is equal to minus 1, is equal to 5 into, this is 8 minus 1, so that leaves us 7, right, and this is 2 minus 1, that is 1, so that is 35 here, right? So a is equal to 35. Similarly, we can multiply this with s plus 2. So this will give us, multiplying with s plus 2. So let's call this, for example, let's call this equation 1. and let's call this 2. So multiplying 2 with s plus 2, so that will be s plus 2 v naught is equal to 5 into s plus 8 divided by, so this will be s plus 1, right? And that will be equal to s plus 2 over s plus 1 a plus b, right? So now we put s plus 2 is equal to 0. Let s plus 2 is equal to 0, that is s is equal to minus 2. So when we put s plus 2 is equal to 0, this term will disappear and this will leave us with b. So b will be equal to this. So b is equal to this s plus 2 multiplied by v naught, while s is equal to minus 2, and that will be equal to, let's put s is equal to minus 2 here. So this will be 5 into 8 minus 2 is 6, and minus 2 plus 1 is minus 1, right? So that is minus 30. So b is equal to minus 30. So we can now rewrite v naught of s is equal to, a is equal to 35. So 35 over s plus 1 minus 30 over s plus 2. So we know that the Laplace transform e raised power minus at is equal to 1 over s plus a. So this is s plus a, this is s plus a here is 1 and a here is 2. So the Laplace transform of using the linearity property for this is 35 e raised power minus t, a is 1 here, and for this this will be 30 and e raised power a is 2 here, so this is minus 2t, and we can write u of t here to emphasize that the response is for t is for t is greater than or equal to 0. So this gives us the voltage across the capacitor for t greater than or equal to 0 in the presence of the initial conditions, these initial conditions. So with the use of the Laplace transform, the initial conditions are automatically incorporated in this circuit, right? And we do not need to apply the initial conditions later on. These are automatically incorporated in the transform circuit, and with the solution of this transform circuit we arrive at the value of the v naught s in the frequency domain, and then we can apply inverse Laplace transform to arrive at this solution, which includes the result due to initial conditions as well.